I presume I do not have to explain you what is kNN classification, which is K nearest neighbor classification. If you need a video on that, do let me know. Now, the first thing what I do in all my R programs is I clear the environment, right? Which is this rmlist ls command. Then I load the library class. Then I load the iris data set, and I just check the iris data set. You can see it has 5 columns. The first 4 are numeric columns: sepal length, sepal width, petal length, petal width, and fifth is species. So I also do one more thing, that rather than taking the whole of the iris data set, I just take the 90% of the iris data set as my training data and the 10% as my test data. Now over here I'm taking the 90% as a random sample. That is why I have to use this sample command. Now obviously there's nothing like truly random. It's, you can think of it as a pseudo random thing. So I run this command. You can see this command over here, sample 1 to n row iris, 0.9 into n row iris, right? So just run this command. And then I also create a function which will normalize my data. If I look at the sepal length, sepal width, petal length and petal width, they all come from different ranges, right? Sepal length is somewhere around 4, 5, sepal width somewhere around 3, petal length is around 1 and petal width is around 0.2, 0.4. So I need to normalize these numbers so that whatever distance metric which I will be computing, it has some meaning, because you know that in k nearest neighbor everything is all about the distance metric, right? So I run this function and then I use this function. To use this function, what I do is I use lapply. Now if you don't know what is lapply, you can google it up, or you can just comment down the video. I could make a video on lapply as well. So I use this and then just I check it once. You see everything, sepal length, sepal width, petal length, petal width, it has been changed to 0 to 1. You see min is 0, max is 1 in all the columns. I have not touched the species. You can see from my 11th line over here, I am just taking the column 1, 2, 3, 4 because species is not a numeric column, so I will not touch that. Then I will split the data into training and test using my RAN. You see the 6th line, I drew a 90% index for the samples. So I use that index thing for training and test and category separately. And then I have to create a function for my kNN classification. You see this function which begins from 19th line. This function essentially is your kNN classification function, and I can test this function in the 28th line using k equal to 3. So what it does is this function takes an input which is k, the number of neighbors which I have to consider. The PR thing over here is the kNN model, right? It is using the iris train, iris test, and it is using the iris target category, okay? And k is equal to x because see I'm supplying k from here. That is why I have to put over here this k equal to x thing. Now tab, what is tab? Tab is just a table for my model result and the actual iris test category, right? Over here I am using iris target category for training, and over here iris test category for checking what is the accuracy. Then I have to make accuracy function also to check what is the accuracy for the scaling classifier. So I just do the sum of the diagonals by sum of the row sums, which means that I just need to check the main diagonal because that is where the true classification has been done, right? Let me run this function now. Now let's check it for k equal to 3. So you see, if I do use k equal to 3, I get 86.66667%. Now just a word of caution that I'm using a random sample to train, right? So your random sample could be different from my random sample, right? So you might not get this classification accuracy for 3 neighbors. You might get it, you might not get it, because my random sample is not going to remain the same always. It will change as many times I run this code. This RAN thing will change, so training data will change, test data will change, so obviously my accuracy could change. That is why you do not have to take these numbers to heart. Now if I have done this for 3, I know that this function thing over here is working. Now let's try to do one more thing. Let's change the value of k in kNN from 1 to 100, right? So for that, what we'll do is we'll first make an accuracy vector over here which is empty as of now. Let's create it. And then store the accuracy of here using the append function here in the st accuracy vector, right? So let's just do this. So now you can also check what is the current state of this st accuracy. You see it starts with 86.66 and then goes up to 93 for k value of 33, for k value of 4, then drops, then rises, then for large values of k the accuracy is very low. Now you don't have to get into the analysis stage as of now. And if we just had two classes, over here we have three classes. If we had two classes, I would have also liked to calculate the precision and recall numbers. If you want, you can also take a screenshot of this code or just pause this video now and copy it down in your system. If you like this video, do give it a thumbs up and don't forget to subscribe if you are new.